calculus problems. Okay, so we are pursuing still discussion into pseudo calculus problems, and then we are in a phase of deep discussion on the on the on the repeated summation that leads to integration. Repeated summation, it leads to integration, and then what is the how we can get to integration from the repeated addition. We have seen repeated addition that would yield area of a circle. If I have a circle, then make a n part of the circle in a radial fashion. Take the radius and make n part of the circle and calculate each part area and add it. It will become the area circle. Why we are giving this much focus is that in future in artificial intelligence area where statistics and probability will come into the picture, this will play a major role in a way to come to a solution to the problem. If problem is there, then typically people they find solution, making the problem into different part and adding it separately, and then solution is there. Okay, in that fashion, we tried calculating the perimeter of the circle also. Same thing, we divided the perimeter of circle in many subsections, and then each subsection we calculated the length and then we added it. This is called repeated summation or summation to get the perimeter or area of anything, to get the solution of anything. If problem is there, divide the problem area solution domain into many parts, add each part, and it would bring the solution. Okay, in that fashion, we have found that if I am trying to calculate area, then if I divide the circle into I part, please watch our previous video. If I see divide, this is the radius and this is the center. If radius moves like this, then one movement, it makes one section in the circle. Next movement, next section in the circle. Next movement, next section in the circle. Next movement, next section in the circle. Like that, we are making n section of a circle. If we are making n section of the circle, each section area, if I add n, then we get the area of the circle. Summation sign I equal to 1 to n. Area, bottom right small I, AI, area of the ith section. If I add, we can get the area of a circle. Is it that easy? Certainly it is that easy one. How to get the perimeter of a circle? How to get the complete arc of a circle? Divide the arc into many sections. If this is x-axis, take the radius and move like this. This is the first section of the arc, second section of the arc, third section of the arc. Like that, keep moving and make n section of the arc. Consider one section of the arc length is p, then ith section arc length is pi. Summation of I equal to 1 to n, capital P and bottom right small I, pi, subscript pi. This is the perimeter of the circle. Was it that easy? Certainly it is. But we know that there is a pi comes into the picture and whose value is not highly determinant. I believe, I don't remember the what is the pi value. I believe 22 by 7. 22 by 7 is the pi value. This is what I think so. Anyway, otherwise it's 3.14 and so infinite. So the perimeter of circle was that easy. We heard it is 2 pi r, where r is constant. Then only perimeter of circle is 2 pi r. If r is function over theta, the way we have example that r equal to cos theta. If someone just draw a circle with expression r equal to cos theta, it also makes a circle. But that circle will be centered at 1.1 by 2 comma 0 rather than 0 comma 0. Someone can draw it. R equal to cos theta. The circle will be 1 by 2 comma 0 centered circle with radius 1 by 2, that is r equal to cos theta. So r is function over theta in the sense that radius will be drawn from the origin only, but it will draw circle that is not centered at the origin. Is it not that something highly surprising? Radius is drawn keeping one end of the line at the center only. If this is the center, the radius will start moving like this only, and it will form a circle which will be centered not at the origin at 1 by 2 comma 0. That is r is a function over theta, r equal to cos theta. If I draw a circle r equal to sine theta, again I can draw keeping radius one end at origin only and draw in this fashion. But the circle will come, it will be centered at the y-axis 0.0 comma 1 by 2, and it will form a circle of radius 1 by 2. So this is a radius is function over theta. Okay, now we have found that if I'm trying to find the ith section area, if area I make many sections, the ith section of the area is if I'm talking about ith section, then it makes angle called delta theta I. If there is a ith section, if I divide circle into many area, one area will have two sides as radius and one side as arc, where these radius may not be the same. Makes sense? Why this radius may not be the same? Because radius is function over theta. If theta is 0, then this is the radius. This is origin. But if theta is theta, then this radius and this radius are not same. Radius may increase, radius may decrease. At any point, consider this is the radius and that length is r1. If I move delta theta I it makes ith section. This is r2. R2 and r1 may not be the same. In that fashion, this is the arc. We calculated that area of this section is 1 by 2 r2 into r1 delta theta I. This is what we computed. And then through reverse manner, through the one is that repeated summation would lead into integration. Repeated summation would lead into integration. To verify it, our repeated summation, because repeated summation typically will make assumption that if this is R1 and this is R2 and it make an arc, then area of this more or less it makes a right angle triangle where base is R2 and this arc is the perpendicular. Arc falls on the base R2 as perpendicular straight line, though it is not a straight line, but a straight line whose length is R1 delta theta I. R1 delta theta I into R2 by 2 will give this triangle's area. If this is the area of the ith section of the ith wedge of the circle, the net area would be summation sine I equal to 1 to n and then 1 by 2, and then if I consider this r1 and r2 as function over theta, then function over theta delta theta I, function over theta whole square. One is function over theta, another is again function over theta. Function over theta whole square delta theta I. If I am adding something like this, I want to make it very clear that if someone is trying to transform summation into integral calculus, then all the spikes, how we compute the integral calculus, that is a big question. How we compute the integral calculus? If we want to compute a summation, how we convert a summation into integral calculus? Consider this is x-axis, and along the x-axis, I have many spikes. These are the collected value. Consider x-axis is the time. Along the time, I have many measurement. When time equal to 0, when we started, at that time I have one measurement. When time equal to 1, I have one measurement. When time equal to 2, I have one measurement. When time equal to 9, I have one measurement. Okay, if I add all these measurements, and then how I can write this? Consider the first measurement is function over time. First measurement is y0. Second measurement is y1. Third measurement is y2. Okay, first measurement at time equal to 0 is y0, y1, y2. When 9, it is 9, it is y9. Okay, in that fashion, it will be summation of I equal to 0 to I equal to 9, or I equal to 0 to n minus 1 if there are 10, n verticals we have generated. Y bottom right I equal to 0 to 9 yi. This is the summation. Can I write this as integration sign where integration sign y dt? Y is there, right? Y is a height, and it is flowing toward the time axis. This is x axis, that is a time axis, and every time we have a collection of data that we are writing as I equal to 0 to 9. We have made I sections. Each section has gap of one time unit. I equal to 1 to 9 and yi. How I can write it in integration? Can we write it as an integration sign t equal to 0 to 9 yi dt? Can we write like that? yi dt. Okay, is it possible? Certainly not. If I write like this, where y is not dependent upon time, okay, every time y is some independent component, then it will lead to whatever it is, y dt. Integration time equal to 0 to 9, y dt. Y is constant, came outside, dt is t, and t is 9 vague thing. So what about if y is function over time? At different time, y is different, but it is tied to the time. What is tied to the time? If someone really asks what is tied to the time, consider y equal to t. I always give this example, or y equal to 2t. Whatever the time is, that much y we are getting. When time equal to 0, y is 0. When time equal to 1, y is 2. When time equal to 2, y is 4. When time equal to 9, or rather let us start from 1, or okay, 0 is also all right. When time equal to 9, the y is 18. It is tied to the time. In that case, again we can write a summation I equal to 0 to 9 yi. Can it be converted into y dt? T is 0 to 9, certainly. Y is function over time, and instead of y, I can write here 2t, 2t dt, and 0 to 9. It will become 2t square by 2, t square 0 to 9. That is 81. 81 will be the what we are getting. First, we are trying to calculate the summation of y, where each y is collected per unit time. Each y is collected per unit time. In that fashion, that is converted into integration, because per unit time, if I say, we have demonstrated it earlier also. If the sample collection is happening at the per unit time, then whatever the sample value we are taking, the height value or value at any time, that I can multiply with the 1. That is implicit. If I say summation of I equal to 0 to 9 yi, it is same as yi into 1, or someone replace 1 with delta t. Delta t means if at time equal to 1 I have collected a sample, then delta t is the distance between this sample and next sample. Then time equal to 2, I am collecting again a sample. Then delta t, if I multiply, delta t is the difference between this time and next sample. That is 1 constant. But still I can write summation of I equal to 0 to 9 yi delta ti, where delta ti is constant 1. But that is required. Consider that between 0 and 9, including 9 and 0, I make 1000 sampling where data are not coming at regular interval. Data came 1000 sampling. Data came at time equal to 0. Then data came at time equal to 001. Data came at time equal to 1. After that, then data came at time equal to 1 comma 1.01. Then at data came at time equal to 1.05. At irregular interval, data is coming, but between 0 to 9, 1000 sample came. Okay, I can write now summation I equal to 0 to 1000 minus 1. Okay, and then yi. This is the net data that came, y into I. Okay, how I can Can I go with the integration sign here, where time is 0 to 9, because that much it came. Time is 0 to 9. Time is 0 to 9, because from 0 to 9 only this many sample came. Y, that is function, consider that it is function over t only. If I consider that, then it will be like at 0 data is 0, at 0.01 data is 0.01 whole square, at time 1 data is 1 I'm sorry, it is 2 2t. Time at time 0 comma 01 data strength is 0.02. When time is 1.13, at that time data strength is 2.26, like that. So in that fashion data is coming, that is function over time. Now I am writing summation of I equal to 0 to 999, or 1000 minus 1 yi. If I add this like this, can I convert, rather than writing in summation, can I convert this into the integration, that is time equal to 0 to 9, y will convert it into ft, function over t, that is 2t dt? Certainly not, because the gap between each sample is undefined and that is not 1. Okay, is it required that it should be 1? Not required. But net sample, it can adjust only 10 only between 0 to 9. That's it. Means more or less it should be considered as a unit distance gap on average. But here the gap is very minute. So many samples are coming. If I add all those samples, then it will be dot integration. Integration is more or less called width into area. Width into height is called integration. The basic norm of integration is area, width into height. If I take so many samples but width is 0 to 9 only, then height is so many, it will give very high value. If I calculate, if I calculate in a fashion that it is all sample, if I add, okay, in that fashion, then what will be the integration? Integration, if I want, then summation should be different. What should be the summation then? I equal to 0 to 1000 minus 1 yi, or function over t, delta ti, ith section of the delta. Everywhere the delta, if I have the data, if time is 3, the data is 6, that is okay. But next data, when it arrived, next data arrived at time at 3.05. Then I have to multiply the ft, that is the time equal to 3, whatever the data came, that is 6, into whatever the delta t is there. Everywhere height, and if I get a data at particular time, and next data I get a data at time equal to t1, next data I get at time equal to t2. If I am placing this t1 data, then I have to multiply with t2 minus t1. That is the delta ti as ith section. If I have a computation like this, I don't know, everyone has different need on its own. If I have a computation like this, I equal to 0 to 999, or 1000 minus 1, function over t, or yi, function over t, or yi, delta ti, this can be converted into integration, because whatever, so many 1000 sampling we are taking, but at the end with each sample we are multiplying with the width, that is very small. At the end we are normalizing it. Makes sense? Okay, this is typically, then why then okay, we will go with it. Then this is typically, we will see. But this is how it is. We are normalizing the height with the width. Width is very small, much lesser than 1. More or less it will be normalized only. In that fashion, now we can write as integration from 0 to t ft dt, and it will come as t square 81. Okay, even though I am getting 1000 sample, and that is 2t, 1000 sample, that is function is 2t, but it will come as t square only, that is 81. Anyone can add 81. 0 plus 0 plus 1 plus 2, I mean 2t, right? 0, then 2, then 4. Okay, 0 plus 2t, then it will be at time 1 it is 2, time 2 it is 4, 4 to 6, then 6, 12, then 8, 20, then 10, 30, I believe, then 12, 42, and then 14. It will be 56. Okay, then 16. Then it will come as, I believe, 72. I think so, if I'm not wrong. Something like that. Oh, I made something wrong. Okay, at 1, it is 2t. 2t. Then 1, it is 2. 2 plus 4, 6. 6, 12. 8, 20. 10, 30. And then 12, that is 42. Then 14, that is 56. And then 16, 56, 66, 72, and then 18, it will come as 90. What we have calculated is t square by 2, t square by 2, that is 0 to 9, that is 81. More or less it is similar. If I had calculated 1 to 10, someone can try. Okay, that is the way of converting summation into integration. Summation should be full place. Okay, but many places I have seen that if it is y function over t, summation function over t only, delta t is not required. And then I convert into integration. There are caveat here. If delta t is there, then it is easy to convert. Otherwise, otherwise you have to make sure that the limit you are placing, it should be it should be same. If it is I equal to 0 to 999, then time will be 0 to 999. Then ft dt will work. So the gap will be 1. Delta t, hidden delta ti will be 1. No, time is 0, then it's not possible. Anyway, now we are in phase of calculating the summation into the integral calculus. That is the idea. If I talk about different section in the area while calculating the full area, AI, summation of I equal to 1 to n, capital AI, where ith section area of the circle is, if entry radius is r1 and exit radius is r2 and angle is delta theta I, 1 by 2 R2, R1 delta theta I, that is the R. Please watch our previous video. And that is resolved into 1 by 2 function over theta, delta theta, summation I equal to 1 to n. That will resolve into 1 by 2 function over theta whole square, delta theta I, summation. Now, it is a fit case. Can someone match it what I am saying? Function over theta whole square delta theta I means function over theta whole square is the height and delta theta I is the gap. It can be nicely converted into integration. That is integration now where the theta span, not the I is 1 to n where n tends to infinity. We don't need to write integration where theta tends to infinity. Variable is theta here, delta theta I. Theta spans from one place to another place, how much it is. If I am talking about r equal to cos theta circle, then theta spans only 180 degree to make a circle. Please watch our previous video. R equal to cos theta, radius equal to cos theta function. It actually deals in making a circle that has radius of that has angle of pi only. Theta is 0 to pi, 1 by 2 function over theta whole square d theta. Nicely it can be converted. We will do tons of example in the repeated summation because that is the lifeline of artificial intelligence. That's why we brought in this picture. So the base should be strong. Anyway, now we are in phase of validating the repeated sum. We are validating the repeated, we validate the area also. We are validating the repeated sum of calculating the circumference. How to calculate the circumference? We have seen to calculate the circumference. Now this is the radius that is moving and it stick at a point where radius is r1 and or r, and then it moves delta theta I and it makes an arc. This is the ith section arc. Now if I want to calculate the full circumference, then I equal to 1 to n where we have made n section in the circle. I equal to 1 to n and then I equal to 1 to n and this perimeter P I, capital P, bottom right small I, summation sign sigma sign I equal to 1 to n, perimeter of the ith section. If I add all the parameter along the circle, if this is a full circle, and I have made n section along the parameter. Then ith section I am talking. If I am talking about the ith section of the parameter, this is the radius, first radius. Radius move delta theta, it come here. What is the parameter here? Then we saw the parameter here is, if I see this as x axis and this is y axis, then if item is moving, if radius, this is the radius, at any go, radius is moving from x-axis at any time radius is here. Then it moves delta theta I. When radius is moving delta theta I, consider this point at x comma y, and it moved delta theta I, and this point is x2 comma y2. If that is the case, if this is x comma y and x2 comma y2, then if this is the arc, that is the arc of the ith section pi, then this arc moved delta x along x-axis and it moved delta y along y-axis to make x comma y to x2 comma y2. In that sense, this arc, this forms a triangle. This is delta x, this is delta y, and this is the side, base, height, perpendicular height, and this is the side. If delta theta I angle is very small, I can consider this arc as a straight line. If that is a straight line, if this is delta x and this is delta y and connecting point is the straight line, I can say this line, that is the arc, is delta x whole square plus delta y whole square root. Means ith section parameter is square root of delta x ith section delta x whole square plus delta y whole square. Summation of I equal to 1 to n, it gives the parameter. This will be started and we computed the parameter of the circle. But situation is how I can validate this, that our fundamental is right. What is your fundamental that is right? Anyone would ask. Fundamental is we calculated the ith section perimeter as square root of delta xi whole square plus delta yi whole square. Summation I equal to 1 to n. This is what we calculated for the ith section. Okay, then it can be transformed into integration. Integration sign square root of delta xi will become dx square plus delta yi would become dy square, where y is function over x as far as it is a circle is concerned. If it is a circle as centered at the origin, then y square plus x square equal to a square. If this circle is not centered at the origin, in a case r equal to cos theta. If there is a function radius equal to cos theta, it also forms a circle centered at 1 by 2 comma 0 and radius is 1 by 2. In that way, the equation of the circle will be x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. Y equal to 1 by 2 whole square, 1 by 4, 1 by 2 whole square minus in bracket x minus 1 by 2 whole square root. Dy equal to, if this is y, then what will be dy? Someone can calculate. It will come in the form of x and dx only. Then the square root of dx whole square plus dy whole square, whatever we calculated here. Integration x is, if x is moving from here to here, how much it is traversing? If the circle is centered at 1.2 with radius 1 by 2, then x would travel 1 to 0. Then x is 1 to 0 if I am making it anti-clockwise, or 0 to 1, then square root dx whole square plus dy whole square, where y equal to square root 1 by 2, 1 by 2 or 1 by 2 whole square plus x minus 1 by 2 whole square. Dy someone has to calculate and solve it. It will give the perimeter of the circle, that is r equal to cos theta. How we can validate this? This is the question mark. How we can validate this? To validate this, we have done so many things. Validating this means we came to this integration from the repeated summation. Can we bring this integration from somewhere else and see it is same? Makes sense? If this repeated summation brings integration, to validate this integration is all right, because we have made assumption here. Now in this, can we get to this integration from other direction and see repeated addition integration and other direction integration, they are exactly same. How we can get it? One way is very peculiar way, very different way. What is your different way? One way that is very peculiar out here is, consider this radius is moving like this. Radius is now at rest position at x equal to 0. This is x axis, y axis. Radius started and it stopped here when it is making angle theta. Now at this point, this is x comma y. At this point, this is x comma y. Radius moved delta theta I, and this is x2 comma y2. How much it moved? Okay, this moved from x comma y to x2 comma y, x2 comma y2. If I make a straight line, this is not the perimeter. Perimeter is round shape that will go from x comma y to x2 comma y2. How I know this round shape line? If the perimeter is becoming round and it is one, when radius is at one position and this point is x comma y, then radius move delta theta ith section, and it is x2 comma y2. Radius, the end point of the radius move in a circular fashion. It is not a straight line. If I say I know x comma y, and then I know x2 comma y2, if I know these 2 points, then I can draw a vector. Then I know the vector, but that is a straight line, not the curved line. Okay, how to get the curved line? Now let's say that now radius is here, radius is here. Now I make a very small movement in radius. The angle is infinitesimally small. The angle is 1 unit of angle. Unit is not 1 radian. 1 unit is 1 picoradian. Consider I divide this radian, that is 2 pi. If I move full 2 pi into one, I have one unit called picoradian. Pico means 10 into 10, 10 into, how much it is? 1 into 10, 10 to the power minus 12. 10 to the power minus 12 is the picometer. So I have 1 unit as picometer, picoradian, that much small. Now from here, this is point x comma y. I moved 1 picometer, very slight. Then I x comma y moved to another point. Then again I moved very small, another point. Then I moved very small, another point. I moved very small, then another point. Like that, I kept moving, and finally I came to position. From the beginning to this end, this angle is delta theta I, and this point is x2 y2. Means if I keep changing p with the slight movement in angle theta, I start visiting different points. If I combine all these points, then it will more or less, it will become a curved line. Even though if I have moved 1 picometer also, and it has, consider it has reached another point, that is alpha comma beta, then x comma y to alpha comma beta, if I draw a straight line, that will again be deviating from the actual curve, but it is very small. In that fashion, if I keep moving, then I have innumerous points that I have connected to come to x2 comma y2. Now we more or less, we have a arc. Okay, if I divide, what are you trying to say? I'm trying to say, if you take innumerous points between x comma y to x2 comma y2, innumerous point where the radius is moving, innumerous point radius is moving, when it makes full delta theta I, then if I connect all these points, then it will more or less arc. What are you talking? If I move away 1 unit chain, micro unit chain, what it is called? If I make 1 unit, it is plausible, I believe. It is, I'm sorry, I'm not sorry, I'm sorry, it is not, it is plausible. Okay, so it is a kind of it has some logic now. If I divide, if I make move radius move small one pico radian, one pico radian, then there will be innumerous points between x comma y to x2 comma y2. But how much p has moved if I move 1 picoradian? That is the question. How much p moved? P moved x comma y to alpha comma beta. That is true. Okay, when I move angle 1 picoradian. But how much this moved as far as x comma y to alpha comma y? How I know? That is called, if I say x comma y as point P, then P move from P to P1, where P1 is alpha comma beta. That is called change in P when I have change in 1 radian, 1 picoradian. Okay, if there is 1 pico, how I can control this movement? How I can nomenclate this movement? This movement is happening because the angle we moved is 1 picoradian. Angle we moved is 1 picoradian. That is called how much p moved because we moved angle 1 picoradian. That is also called, this is P1 and this is P. P1 minus P by 1 means dP by d theta. Okay, I believe it is all right. How much P change? I'm sorry, I will make it even simple. How much P as a point it changed if I moved angle 1? Okay, if that is the case, then I can write it as P by angle. P by angle means per unit movement in the angle may is how much is P. I believe it is all right. Okay, how much how much P we collect? How much P we collect? That is alpha comma beta minus x comma y. That much is the P we collect. A person is moving from one location to other location, we say how many kilometer he collected. Similarly, if something is moving from x comma y to alpha comma beta, how much distance he collected per unit angle movement. That it can also be say p by theta. P by theta per unit of theta brings how many unit in p? P by theta. That is alpha comma beta, that is 1 point minus x comma y in abstract term by 1 picoradian. Okay, if I say this movement what you are talking, that is x comma y and alpha comma beta minus x comma y, the movement you are saying, that is governed by delta theta I. Means this movement is function over delta theta I. Makes sense? In that case, we can, if numerator is function over denominator, we can write this as differential calculus. P by 1 picoradian, that is P, difference in P by difference in theta, can be rewritten as dP by d theta. dP by d theta. Change in P per unit change in theta, dP by d theta. dP by d theta tells us if I move 1 unit of radian, then how many unit P changes? dP by d theta. P changes per unit radian. That now how much P would change if I move delta theta I radian? Makes sense? P is changing. P, if I say P change from P to P1, that is dP, change in P, because I moved theta angle 1 unit, that is dP by d theta. Then I'm trying to calculate ith section parameter, that is delta theta I. Then we can say the full change what we are saying, immediately it is changing, right? Then full perimeter length is dP by d theta into delta theta I. Okay, where we have to calculate magnitude of dP by d theta, because P will typically, if I place P is x comma y, how I can represent alpha minus beta comma x comma y? Not possible. I can subtract x with alpha and y with beta, but alpha comma beta minus x comma y, that is change in P when there is 1 picometer of radian change. Rather than that, we can represent both point P as a position vector, because difference will lead to the vector only. If this is the position vector of x comma y and this is the position vector of alpha comma beta, if I subtract these two, another vector will come that will be along the x comma y and alpha comma beta. X comma y and alpha comma beta, one vector will come, and that will be difference of p vector and p1 vector. Another vector will come, that is in direction what we want. Okay, in that fashion, if I want this distance, then I have to calculate magnitude of that vector. Then only we'll get this distance. So if I say dP by d theta, then where dP change in position, or if someone, okay, I'm sorry, if someone is trying to find what is alpha minus beta comma x comma y, the distance we are talking per pico radian change, then someone can say we can calculate through Pythagoras theorem. Then it will come a direct subtraction is not possible. It is more or less, it is something like it is abstract only. Alpha comma beta minus x comma y. Someone can say this is actually alpha minus x whole square plus beta minus y whole square root. That is the distance covered when I make one unit change. dp by dx, dp by d theta is a square root of alpha minus x whole square plus beta minus y whole square. Alpha minus x whole square plus beta minus y whole square, a square root, it is nothing but the magnitude of a vector, that is alpha minus xi plus beta minus yj. That is the nothing but p1 vector minus p vector. P1 is alpha I plus beta j, and p vector, that is x comma y, is xi plus yj. P1 minus P, if I say, that will come as alpha minus xi plus beta minus yj. This magnitude is exactly same what we are talking. Alpha minus x whole square plus beta minus y whole square root. Means what we are talking, if I move 1 picoradian forward, then how much x comma y change to alpha comma y? What is the distance we are seeing? That distance is nothing but alpha minus x whole square plus beta minus y whole square root. That is nothing but P1 vector, that is alpha I plus beta j vector minus xi minus yj vector. Means dp by d theta is nothing but d of p1 minus p, d of p1 minus p by d theta. Whatever it is, this is how it is. dp by d theta. Okay, I'm sorry, I'm really sorry. Okay, dp by d theta means how much p change per unit theta. I can write it as p1 minus p by 1. That is the 1 picometer, picoradian I forwarded. p1 minus p by 1. p1 minus p I can write as d of p. D means change in position vector. Change in position vector by change in theta. More or less it comes as dp by d theta, where dp is p1 minus p, that is a vector. If I calculate dp by d theta, that will be a vector, but I want the distance, not the vector. Okay, then I have to say magnitude. This magnitude is alpha minus x whole square plus beta minus y whole square root. Otherwise, dp by d theta, where theta is 1 radian, is p1 minus p. That is alpha minus xi plus beta minus yj. Okay, but this is not we want. We want the distance is covered when 1 picoradian change. So we can say magnitude of dp by d theta. Then what is the full arc it change when it is delta theta I into delta theta I? This is the arc of the IS section. Okay, that is dp by d theta magnitude into delta theta I. Okay, delta theta I can write as d theta. So more or less it becomes dp by d theta magnitude d theta. This is the integral sign, but looks like it is also looks like a summation, right? Summation means summing I equal to 1 to n and dp by d theta and delta theta I. Okay, that is derivative of p with respect to theta. If p is function over theta, then derivative of p with respect to theta, delta theta I, it will converted into dp by d theta magnitude d theta, whatever it is. From that side also we can directly say this is the ith section parameter is dp by d theta magnitude d theta delta theta I, or through this way someone can proceed in the repeated summation also, but whatever it is, it will come as integration theta from one location to another location dp by d theta d theta. Okay, someone can say through summation also I can understand this, that is dp by d theta magnitude delta theta I. If I add for all the section, it will become dp by d theta magnitude d theta only. Okay, nice. If someone understand, very nice. Through this way, through vector way, what we have got, then we have to solve it. What to solve it? What is p? P is xi plus yj dp by d theta xi plus yj. What is x? R cos theta. What is y? R sin theta. D of r cos theta I plus r sin theta j. by d theta magnitude d theta. Okay, d of r cos theta I by d theta I plus d of r sine theta by d theta j. Now first will come where if r is function over theta, then it will come as r d cos theta by d theta plus cos theta dr by d theta bracket I plus r d sine theta by d theta plus sine theta dr by d theta j. And this is the then magnitude. Then someone has to square it and square it and square root d theta. It will come as the square root of dr by d theta whole square plus r square. If someone can try it, we have done it in the past video. Square root of dr by d theta plus d theta whole square and then d theta. Okay, dr by d theta, dr by d theta whole square plus r square, square root d theta. Okay, from the repeated summation, what we had brought in, repeated summation we had brought in, a square root of dx whole square plus dy whole square is the parameter. Integration sign theta from one location to another. If I place x equal to r cos theta and if I place y equal to r sin theta and place there a square root of dx whole square plus dy whole square, it will exactly come as same what we are calculating through vector. Through repeated summation, where if this point is moving from here to here making delta theta I, it moves delta xi, delta yi, then this arc is considering it as a straight line. That arc is delta xi whole square plus delta yi whole square root. Then I sum it for all the section. It is I equal to 1 to n square root delta xi whole square plus delta yi whole square, that equivalent to integration square root dx whole square plus dy whole square. If someone keep x equal to r cos theta, that is a polar coordinate, y equal to r sin theta, where r is function over theta. Now place it here, dx will become d of r cos theta, that will become r d cos theta by d theta plus cos theta dr by d theta bracket d theta plus dy, that will come as r d sine theta by d theta plus sine theta dr by d theta bracket d theta. If someone solve it, it will become a square root of dr by d theta whole square plus r square d theta only. The way we are bringing in through vector, that the net circumference is integration of the theta and then magnitude of dp by d theta. This is we are bringing from the vector. What is magnitude of dp by d theta? P is xi plus yj. If x is r cos theta and y r sin theta, d of r cos theta I plus d of r sin theta j by d theta. If someone compute it, then someone has to calculate the magnitude. X component whole square plus y component whole square root and then d theta. It both will be exactly the same. Means we validate that repeated summation indeed it makes sense provided the approximation what we took, that the arc it is small for the delta theta and it is a straight line and it is equivalent to delta x whole square delta y whole square. It should be perfect. If it is perfect, then repeated summation can be taken converting into integration. Someone can try in polar coordinate system. dp by d theta magnitude d theta. Polar coordinate system, the position vector p will be r unit vector plus r theta unit vector by d theta. Then in that fashion it becomes dr by d theta r unit vector plus r d theta by d theta unit vector. Okay, that will become r dr by d theta r unit vector plus r theta unit vector. If someone calculate magnitude of it, it will become dr by d theta whole square plus r square root. Okay, someone can ask this question, every time we are taking theta as independent variable, can we take r as independent? Because radius is also changing, right? Radius is not constant. R equal to cos theta. I can also write theta equal to cos inverse r, where r is independent component and radius is changing. I'm not saying theta is changing. Radius is changing slowly. Okay, and theta as a function of radius. Can I see in this fashion and go ahead? Someone can go ahead. Then in that sense, the net circumference will be integration where r is the limit, and then dp by dr per variation, unit variation in r, how much position is changing. This probably people would not get from the repeated summation, but through vector sum one can get dp by dr magnitude and then dr, where P is r cos theta I xi plus yj, r cos theta I plus r sin theta j by dr, where r and theta are tied to each other, they are not independent. Dr, radius from one location to another location. Okay, where radius is changing, radius is not constant. Okay, this someone can consider as an assignment and someone can calculate. Okay, thank you very much. What about dp by dx? How much position vector x comma y to alpha comma beta it is changing if I make change? You can try that fashion also. dp by dx into dx makes sense. dp by dx, where p is xi plus yj. No, this is not possible. Certainly it is possible. If p is xi plus yj, dp by dx is I plus dy by dxj. Magnitude dx. X is, if it is moving like this, x is from one end to another one. Someone can try this also. This will also give the perimeter. These are not available in any of the book. Calculating the parameter through the summation, repeated summation, and then validating it through vector in this fashion. Now we will move it to proving the same thing through the for the area. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone.